In this example, I'm going to do a chain rule, and we'll find the derivative of the square root of t squared minus 1. And I'm going to do it in 3 different ways, using the z notation, and using the fill the box notation, and what I call the in your head notation. And I would not encourage a student to do it all 3 ways. You should find the way that makes the most sense for you. But I think even if you end up using, let's say, the z notation, it might help to just look at the other ways, and that might help you see how the different parts of this problem fit together. Okay, so let's start with the z notation. I'm first going to put the chain rule formula on the screen so that we remember it. dy over dt equals dy over dz times dz over dt. And of course, these d's just mean derivatives. So this is saying to find the derivative of y, you should find the derivative of y with respect to z and multiply by the derivative of z with respect to t. Let me also remind you what the formula is. Y equals the square root of t squared minus 1. Okay, so our first step is to take that formula, that function, and just rewrite it using z, so that helps us break the complicated formula into 2 simpler parts. So first, z equals t squared minus 1. That's the part inside of the square root. Once I write that, then I can tell you a new way to write y. Y equals the square root of z. Now those 2 formulas you could look at, and you could see if you combine them, you'll go back to the original formula for y. But we're not going to combine them. We're going to use them the way they are because they are easier to take derivatives of. All right, let's start with the derivative of y. So you first have to get used to seeing that square root of z is the same as z to the 1/2, because I will use the power rule to take that derivative. So dy over dz, I bring the 1/2 down in front, and then I subtract 1 from the power, so the positive 1/2 becomes a negative 1/2. All right, let's take the derivative of z now. The derivative of t squared minus 1 with respect to t. That's just 2t. So the 2 on the t squared comes down in front, and then you subtract 1. And now we should multiply these 2 formulas together, because that's the chain rule that we have. So the derivative of y with respect to t is 1/2 z to the negative 1/2 times 2t. Okay, that's the derivative, but I should clean up and get rid of that z, which after all we put into the problem. It wasn't there at the very beginning, so we have to get rid of it at the end so that our final formula has only t's in it. And we'll put the t squared minus 1 back in. So my final answer is 1/2 t squared minus 1 to the negative 1/2 times 2t. Okay, let's do the problem again, but this time I'll use the fill the box notation. And what I mean by that is I will write the usual derivative rule like I would have for x, but I will write it with a box in place of x. And then we will fill it by putting, I guess in this case, t squared minus 1 inside. So here's the usual power rule. Box to the n, when you take the derivative, becomes n times box to the n minus 1, and then times the derivative of whatever is inside the box. In this case, we will write it with 1/2. So that's the derivative of box to the 1/2 equals 1/2 times box to the negative 1/2 times the derivative of whatever is inside the box. And we're going to fill that with a longer formula. So let me start by rewriting it where the box is bigger. So now I have room to write something inside that. I'm going to write inside of each box t squared minus 1. So what that says is the derivative of t squared minus 1 to the 1/2, that's on the left, equals 1/2 times t squared minus 1 to the negative 1/2 times, and then I still have one more derivative left to take, the derivative of that last box, the derivative of t squared minus 1. So I will take that derivative, and I will remove the boxes, and my final answer is 1/2 t squared minus 1 to the negative 1/2 times 2t. Okay, let me do it one more time with in your head notation. So by that I mean that I will just kind of say the right thing at the right time to take the derivative of each part. So this is the derivative of the outside. Don't change the inside. And then multiply by the derivative of the inside. And I'm going to color code the parts of these formulas according to these steps. So I'm going to make the derivative of the outside red, the part that's inside that doesn't change blue, and then the derivative of the inside that we multiply by in green. Okay, so here's the original formula, the derivative of the square root of t squared minus 1. And of course, the first thing I should do is rewrite that with a 1/2 power, so that that's the power rule that I will use. The next thing I'm going to do is identify what is the inside and what is the outside. So the inside is in blue, that's the t squared minus 1, and the outside are these parentheses to the 1/2. Okay, now I'll start actually applying the rule. Let's take the derivative of the outside. That's the part with the parentheses to the 1/2. So the 1/2 will come down in front, and then I will have the parentheses, and then I will subtract 1 from that power. So 1/2 parentheses to the negative 1/2. That's the outside, the derivative of the outside. Now I'm not going to change the inside, so I'll just put t squared minus 1 back in. And then I should multiply by the derivative of the inside. I usually do this as a separate step, the finishing the derivative as a separate step, but I will write the prime and the inside part there to remind me that's the last thing. So times t squared minus 1 prime, meaning I haven't taken that derivative yet, but I will on the next step. Okay, the next step is that part becomes 2t, and that's my final answer, 1/2 t squared minus 1 to the negative 1/2 times 2t. Pick whichever version you like, but I hope that at least this colored version does show you a little more clearly the different parts of the formula and what happens to them.